Hi folks, thanks to be here for this talk about containerizing Java application. I'm Nicolas Fränkel. I'm a developer for a long time, and a couple of years ago I started my journey to being a developer advocate. I'm curious about containerization and Docker and Kubernetes. I work for a company called Hazelcast. Hazelcast has a product called the Hazelcast platform, and it has two capabilities. The first one is an in-memory data grid, so you can store values in different data structures and in a distributed way. And the other capability is we do distributed in-memory stream processing. I won't talk about Hazelcast, I will just use it for my demos. If you want to know more, in the last slide, I have a couple of references. So let's start from the easiest part. How you do containerize a Python application? Well, you start from a base image, then you add your dependencies, then you add your code, and then you're ready to run. You want to do the same with Node.js application? Well, the process is quite the same. You start from a base image, you add your dependencies, you add your source code, and you're ready to run. The common factor here is for scripting languages, there is no compilation phase. Whereas in Java, you first need to compile your source code to bytecode, then to wrap it into a dedicated archive, then only then you are ready to run. So for scripting languages, what you see is what you run. For Java application, it's a bit more involved. My demo here, so in every step of this talk, I will try to show you some demo, is I want to use this architecture. So I have my application that will be using a library, in that case Hazelcast, then I will be able to store and get values from Hazelcast running in a separate JVM, and this JVM will run inside the Docker image, and I will expose the port so I can interact it with a REST endpoint. So if we want to do that, the first thing that we can do is we create the jar as expected. So I'm using Maven. You can use Gradle as well, but I will be using Maven. So we will be doing Maven package that will get us a jar. We have a Dockerfile. We take this jar, we put it into Dockerfile, we're ready to go. But actually, we can understand pretty quickly that might not be the best of ideas. So the alternative is actually to everything inside the Dockerfile. First, download the dependencies, then compile the source to bytecode, and then build the jar. And the jar is just like a zip with a standard structure. So let's do it. Here, this is exactly what I did. I start from like a JVM, an Alpine one, so my final image is not that huge because my base image is not that huge. I copy everything that's related to my project, then I do the package stuff. The package stuff we've called the compile stuff. I mean, that's Maven lifecycle. So every step we call the previous step. And then I just now have something in my final image and I can just run it. So here I won't rebuild everything, so you will have to take my word on that. But let's try to run it and check how it works. So Docker run. Let me do it from here. It will be much easier. 1.0. I need to start a Hazelcast node. Hazelcast start. So I run this image. It has connected with the node. Here it's a client of this node. We can see here is the server, and now we can try to call it. So I will just curl and put a single value. Yes, and we can check that everything is working. Now I will try to get all values. I get all values, there is a single one, and we can add more values if we want. And again, we've got both of our values. So it holds good on its premise. I'm able, using the application inside of Docker, to access Hazel costs, to store data, to retrieve data. That's the first thing. But it's not as great as we could have it. And the reasons are multiple. The first one is we start from a GDK. We start from a GDK, which means that because we need to compile it, but in the end it makes the final size of the image bigger, and worse, we can compile Java code in the final image, and probably we don't want to compile Java code. The second thing is that we have a manual synchronization between our POM, so the Maven artifact, which says it's version 1.0, and the Docker image. When we actually build the image, it's where we need to set the version, and it's very easy to make a mistake. And finally, there is no layering. So the whole jar is a single binary inside the Docker image, and every time we change anything in this jar, well, we need to redo everything, which will take time. So how can we improve upon that? Well, the first thing to know is we can use multi-stage builds. So the idea behind multi-stage builds is we can separate our build into different stages, and then we can use different base image for each and reuse stuff from the previous steps. It's pretty widespread, so I don't think I teach you anything here. There is a huge issue, however, it's not compatible with Scaffold yet. Meaning, Scaffold is the Google tool that allows you, when you are developing, you can push your changes in close to real time to a Kubernetes cluster, so you can already check if everything is working inside your final environment. So multi-stage builds not compatible with Scaffold. However, they work pretty well. So let's see how to do them. So here is a multi-stage build. We start from a GDK because we need to actually build our jar. We, as before, copy everything. Then we create a package, and then we start from a GRE. Of course, we are using Alpine because it makes the final image smaller, and here is just a demo, so we don't need a lot of the things. And then we copy from the previous step the jar. Then we can run it, and we can check that it works. So here, I will stop it. I will start the version 1.1. Yes, it has connected, and normally we should access the Hazel cost storage, so we still have everything. So it still works. Now there is an interesting comment about this approach. In Java application, you are using jars because this is how you distribute codes. But in Docker, we are using images because this is how we are distributing the code. And basically, you have those two wrappers around the codes And in that case, the jar might not be that interesting. So in the Java world, we are used to run jars, but actually when you start with Docker images, then the jar might not be that a good idea. And there are other ways to run Java application. You can run Java directly from class files. However, you need to handle the whole class path issue. And that's the idea behind a plugin called Jib. Jib is provided by Google. It's a standard Maven plugin. You also have a Gradle plugin for that. And Jib allows you to have already this exploded way of running the application. It also is able to push to a remote Docker repo or to your local daemon. It has lots of configuration options. So let's migrate our application to Jib. So here, no more Dockerfile, and we have added everything into our POM. So if you are a Java developer, you are used to Maven or again Gradle, then it's pretty straightforward. And now we can build this application not using Docker build whatever, but Maven. So let's do it. Jib. So everything is inside of Maven. Jib is able to talk to the local Docker daemon or to a remote Docker repo, and it's done. And of course, it works exactly the same way as before. Let's do it. Let's run the application. So Docker run, and now it's version 2.0. And we can curl, and everything is still working. But how does it work inside? So let's dive into the image. Dive and Spring in Docker 2.0. So Dive is a tool that allows you to check the layers inside your image. So here we are able to see we start from, well, the image we specified. Then here we can see the different layers. So there are 4 layers. The first one is the dependencies, because the dependencies are the layer that changes the least in your project. And now afterwards we've got snapshot dependencies that change a little bit more. Then you have resources. Then you have your code, which obviously is the least stable when you are doing the development. That has a very, very good benefit, is that actually if you just change your code and you need to rebuild the image, that Docker will reuse the previous 3 layers, which means you only need to rebuild the previous layer, which is really, really great when you are doing development, because the image will be built very fast. So of course there are other benefits as well, and actually, as I mentioned, there is no Dockerfile. So if you don't want to create your own Dockerfile and think about this stuff, it's already handled for you. You have automatic version synchronization between your POM, so your application version, and the image version. And as I mentioned, you've got layers out of the box. But we are using a Spring Boot application, so perhaps we can leverage some of the advantages of Spring Boot.
Spring Boot itself is able to create a Docker-friendly layered output without zip. However, we must get back to Dockerfile first. So we can layer ourselves. So first to have the dependencies, then to have the sources, and then we can create the jar. Then, and I know it's not great when I say it like that, but this is how it works. We can explode this jar using a specific like JVM parameter, jar modes, layer tools, and that will explode the jar into a structure that we can leverage. And so now we have a structure with dependencies, with snapshot dependencies, with Spring Boot Loader, and with the application. And so we are able here, for example, to say, hey, the Spring Boot Loader, it should be here because probably it's the most stable one, or the dependency is the most stable one, or whatever. So here we can actually like not only change the order, but you can like actually configure your layers. You might have more layers, you might have less layers, you might have layers that make more sense to your projects. And in the end, we can also create this. So we get back to a Dockerfile, not great, but we have more fine-grained control. Everything is completely customizable. And of course, as I mentioned, not great, we get back to Dockerfile. The next step is quite interesting. It leverages Buildpacks. And Buildpack is a tool that is able to understand how you build your project. So it will like sniff the structure of your project, and it will see, hey, here I have a pom.xml, it's a Maven project, or here I have a build.gradle, hey, it's a Gradle project, or here I have a package.json, it's like a Node.js application, this kind of stuff. This is actually quite an old IDE, and it was designed initially by Heroku, and now Heroku and Tanzu, or VMware, have joined together to provide this like IDE, to implement this IDE for the CNCF. So it's backed by the CNCF. And you've got quite a lot of configuration options. So we need to install an additional tool, and we can build our application. So let's do it. So here, this is how you call it. Pack builds the Docker image, and then you use a builder. And then it will do everything that it needs to. It will need the base image, the base builder image, the parent image, and it will detect here what it needs to do. So here it will say, hey, for example, this is a JVM. This is a JVM project. I will need to download a JDK. Hey, this is based on Maven. I will do something with Maven. I'm using Tomcat. I will do something. And this is Spring Boot, blah blah blah. And then afterwards, it will do all the magic, get the JVM by itself. And here you can also have configuration, so you can add some configuration, and it will be done everything automatically. And now this is done. So there are a couple of benefits, as always, but however, there are also issues. First, again, we get back to no Dockerfile, which is good. This is scaffold friendly, this is also good, and we are reusing the layers. So by default, as I mentioned, there are 4 layers. We can reuse any layers we created. So if you customize your layers, it will use it. However, we still have issues. So for example, again, we need to tag the image explicitly, meaning there might be version synchronization. The choice of the parent image so far is like very, very limited. We have no choice.
no, that's not true. We actually have like a small choice, but in general, if you change the parent image, it won't work anymore. In general, the process is super slow. Every time you change a little bit of things, it will like run for ages, and it doesn't seem to catch the intermediate image. At least that's my experience. And of course, we need to rely on an external tool. So it would be much better if that would be just inside our standard build, which is exactly what the Spring Boot Maven plugin does. So instead of using the pack command line, it will do that inside your Maven, or again, Gradle lifecycle, and there are some configuration options inside of your POM, the same as the previous one. So in that case, this is the following, so I will just check. Next version, and then I can do the mvnd Spring Boot build image. So that's the same, but inside the Maven lifecycle, we are doing the exact same steps. Again, it can sniff what we need, the Bellsoft, Java, GRE, the Spring Boot clone bindings, whatever. Whatever is necessary, it will sniff, it will add them, and it will create the application, the Docker image. And here I'm pushing it to the local Docker daemon. In my opinion, it has the same benefits as previously, plus you are now in sync. The POM and the Docker image are now in sync. Again, the biggest downside, in my opinion, is the limited choice of the parent image. But we can do better. Right now, we are actually using the JVM inside the Docker image. And in some cases, this is a bad idea, because you might know that the JVM is very good for long-running process, but the downside is that the startup time is long, the warm-up time is longer, and the memory consumption is even higher. So here what we can do is we can actually use this like configuration option to actually get down to native codes. And you might have heard of the Graal VM project, and that's exactly what we are doing. We can, like here, with just a single environment variable here, boot native image, like have an additional step. So once we have created the classes, so the bytecode, we can take this bytecode and compile it to native code. Of course, with Spring, it might not be that easy. That's why, to make our like the process easier, we will have an intermediate step before. We will take these bytecodes and we will have a Spring plugin, like understand all the annotations and whatever, and create additional classes, additional bytecode, so that the Graal VM ahead of time compiler will have an easier time, like compiling from bytecode to native code. And this is the idea behind this like Spring AOT native Maven plugin. And we can use it in the exact same way. So let me do it again. But now we will have this additional step. After everything has been, the bytecode has been generated, we will create the native code. And it takes a bit time. So here, as you can see, the sniffing
now we see there is nothing related to the JVM. We have the GraalVM and the Spring Boot, but here we have an additional one, native image. So it sniffs that it needs a native image. And now there will be some magic involved, and I need to like speed up time, otherwise this talk will last too long. So let's magic it. And that's done. 8 minutes. 8 minutes something. So that's not something you would do like at every compile step. However, let's check how the image is layered. So dive string in Docker 5.5. So the last layer is actually some like system relative stuff. Here is configuration that is not related to our application. Our application is here. It's 130 megs, but it's completely like native image. There is nothing Java related here. Actually, you can see that if we go through everything, there is nothing Java related. It has a couple of good points. So here, if we like check the images and their respective size, Spring in Docker, we can see that this one is actually nearly the smallest one. It's actually like 196 megs. It's a native image. And the smaller ones here, the only reason they are smaller because they embedded JVM is because they have the choice of their parent image. And I was using Alpine, which is very, very small. Here, the base image is much bigger than Alpine, and that's where the difference comes from. So I hope that in the future versions, they will allow us more choice regarding the choice of parent image, and that we can choose like very, very small ones. To finish this talk, I also would like to mention something about squashing. Sometimes there are like devices so that you can have all your layers, you can squash them into a single layer, and of course you will reclaim some space. And that seems like a good idea. However, I did some try with that, and the gains are very, very small. And besides, when you are squashing, you cannot reuse the previous layer because you have squashed them. And so that makes the overall building and downloading process much, much smaller. So please, in general, don't use squashing. So I've showed you several ways to Dockerize your Java application. I've shown you like the basic do your own stuff Dockerfile way. I've shown you zip. I've shown you how you can use Dockerfile with Spring Boot and also like handle your layers. I've shown you how you can do that with Buildpacks. I've shown you how you can like use Buildpacks but inside Spring Boot, and how finally you can use GraalVM. And of course, all those ways, alternatives are great. You just need to check the one that are like the most useful in your environment. I have, for me, a couple of criteria. For me, the worst is the sync between the POM and the image version, which if you do wrong can wreck a VOC. And the second stuff is always think about how you layers your image. It can be automated for you, like in zip. It can be you do it yourself, like in the Dockerfile. But please be very careful about that.
And yeah, don't worry about image size, worry about your layers. That's the most important point. Thanks for your attention. You can read my blog, follow me on Twitter. If you're interested about the code that I've shown you so far, everything is on GitHub. And if you are interested about Hazel costs, well, you are welcome to join our Slack or attend our free trainings. Thanks a lot for your attention and have a good day.